In our next section, we're going to look at a different variation of the iOS's EasyVPN server configuration, where we are using dynamic virtual tunnel interfaces, or DVTIs, in conjunction with the ISAKMP profiles. We'll also look at another variation of the EasyVPN client that is using the dynamic virtual tunnel interfaces as opposed to the dynamic crypto maps. Now, previously we saw this configuration with the virtual tunnel interfaces when we were replacing a LAN-to-LAN IPsec tunnel that was running between router 1 and 3 that was also using GRE for encapsulation in order for us to allow dynamic routing from the LAN-to-LAN segments, where we were running EHRP on the link between router 3 and 4. We were running then EHRP on the tunnel interface, and then router 1 was also advertising its routes over the tunnel via the dynamic protocol. So the advantage of using the static virtual tunnel interface, or the SVTI, is that we were maintaining the ability to run a dynamic routing over the tunnel, but we were saving the additional overhead of the GRE encapsulation. Now we'll see the dynamic virtual tunnel interface is similar to this, where it gives us the advantage of having an interface associated with the IPsec tunnel, but we don't have the additional overhead of running the GRE encapsulation. So in later sections, when we get into the dynamic multi-point VPN with DMVPN, we'll see one of the potential shortcomings of that design is that you do have the additional GRE encapsulation, where when we look at this for very high bandwidth applications, if we're talking about like 1 gigabit per second or more, then there is a significant amount of bandwidth that is wasted on the extra overhead. So in these examples, we are going to be running router 3 as the EasyVPN server again, and we're going to be taking in two different types of connections. One of them is going to come from the test PC that is running the actual software VPN client on Windows, and one that is coming from router 5 as the EasyVPN remote, or the iOS's EasyVPN client configuration. Now, the key point of this design with the EasyVPN server and client is that we can use any combination of server configs or client configs and end up in the same result. This means that if the server is using the dynamic VTI, the client can be using either the software client, like on our Windows machine. It can be running the regular EasyVPN client in either client mode, network extension mode, or Network Plus, but it could also be running the EasyVPN client with the DVTIs. Then likewise, if router 3 is running the other combination of the config, regardless of whether we're using the dynamic crypto maps or we're using the DVTIs, we're going to have compatibilities between all of them. Now, the reason that we would want to do this, in addition to have an interface associated with the IPsec tunnel, it's going to allow us to configure some additional features like QoS, or with the introduction of the ISAKMP profiles, we have some more granular control over how one particular client's traffic is going to be treated versus another. So for example, here where we have the test PC authenticating to the EasyVPN server, based on the group authentication or based on the user authentication, we could assign this connection to an ISAKMP profile number 1, where this profile says I'm assigned to virtual tunnel interface 1, and based on that VTI, I have certain QoS configurations, maybe I have certain filtering configurations, where we could have the second authentication that is coming in from router 5, we could assign this to a different ISAKMP profile that is going to have different QoS options, different security options, etc. So we'll see the combination of both the virtual tunnel interface and the ISAKMP profile is going to give us some more granular control and a little bit more flexibility than using the dynamic crypto maps with the static ISAKMP policies. So next, let's take a look at the documentation. And just like all of our other IPsec configurations, this is going to be under the secure connectivity portion of the security documentation. Then this is going to be under IPsec VPN, security for VPNs with IPsec, and the IPsec virtual tunnel interface. Now, we did previously see this documentation before when we were configuring the static virtual tunnel interfaces. where again, this is the replacement for the GRE tunnel, but it's saving us that additional encapsulation overhead. Then with the dynamic VTIs, this is going to be the replacement of the dynamic crypto map inside the EasyVPN server config. Now, we'll also see in some later examples, one of the additional advantages of using the virtual tunnel interface is that we can do VRF-aware IPsec, meaning that we have two separate tunnel interfaces or more that are assigned to different virtual routing and forwarding instances, VRF instances. Then depending on how the particular authentication works, the user is going to be assigned to one of these VTIs that ultimately has a separate routing table than the other VTIs. So we're doing security not only in the data plane with the actual encryption by using the ESP or the ESP over a UDP tunnel, but then we're also doing security in the control plane by separating the routing information of certain users versus others. So it's multiple layers of security, not only the data plane with the tunnel, but then actually the control plane with the routing. Now, just like the other examples, we could go through the configuration task list and look at how to configure the IPsec tunnel, how to configure dynamic IPsec, and it's going to give us this numbered step-by-step task list. But when we look at simply the example towards the end, the configuration example of the dynamic VTI as an EasyVPN server, we'll see that a lot of the configuration is similar to the previous IPsec configs, whether they were the LAN-to-LAN or the remote access, because the same step-by-step process is always going to be true. That the first thing that we need to do is define the phase 1 negotiation. That is still defined mainly by the ISAKMP policy. Then we are going to define the phase 2 parameters, which are going to include the crypto transform set. Then if we're trying to do split tunneling, we would have an access list that defines what is the proxy identity for that individual client. And as we know with the VPN server, we're not setting the pure address because the responder, who is the server, doesn't know who the initiator is or who the client is to begin with. Now, what changes with this configuration is that there is no crypto map that is applied to the interface, where instead we have a virtual template interface that is a type tunnel, and the tunnel mode is IPsec IPv4, and the crypto profile is then applied to the tunnel, where it's essentially saying that any traffic that routes to the tunnel is then going to use this profile, which in this case they're calling test VTI1, and test VTI1 is then calling the transform set, which says that we're running triple DES with SHA. That was similar to our static virtual tunnel interface that we saw before. The next step then is to associate the individual VPN users with that tunnel interface. And that's mainly here what the ISAKMP profile is used for, where the ISAKMP profile says that when our phase 1 negotiation occurs, and for the EasyVPN, we know that a portion of this negotiation is to exchange what is the group name and then what is the group authentication, where we have the pre-shared key for the phase 1 authentication. So the user comes in, they're using group named group 1. They're going to authenticate with the password Cisco123. Then they're assigned to this particular ISAKMP profile. It says the profile's name is VPN1-RA. Now, if we look at the sub options here under the ISAKMP profile, we can see just based on this basic example, some of the things that we could set would be the AAA lists. So how are we doing the authentication? How are we doing the authorization? Then additionally, what is the interface that the client is then going to be assigned to? So some of the things that this would allow us to do is, based on the AAA configuration, we could do different types of authentication or different types of authorization depending on what the group name is. Where maybe group number 1, I want to send this to my TACAC server. But for group number 2, maybe I'm going to check the local database. Then group number 3, I'm going to go to a different radio server. Then additionally, since I am also defining the virtual template, which is the actual dynamic virtual tunnel interface, or the DVTI, I can then control the per interface parameters based on the authentication. So someone comes in, the user comes in, they're using group number 1. They're then assigned to virtual template 1, which means that any QoS I have configured on here, or maybe it's part of a zone-based policy firewall configuration. So once the EasyVPN connects, we have a different firewall filtering policy for a certain type of user versus other ones. Maybe we have a template for our administrators that are allowed to telnet or to SSH to the network devices. Then one that is for the basic users, where maybe we'll say allow them to use TCP port 80 and maybe mail traffic like SMTP or POP3 or IMAP. But the key is that since we're now decoupling the phase 1 authentication and applying it on a per group basis, where normally this type of stuff would be global for the particular crypto map. But since we're removing the crypto map and then making it this more modular configuration logic, it gives us more flexibility to the final result of the configuration. So let's take this example that they have here and let's change it around in order to match our particular design. Now again, if we take a look back at the topology, I want to configure router 3 as the server so that it is listening for traffic coming in from the test PC and from router 5. And ultimately, I want traffic that is going to the 172.16.34 network and the 172.16.4 network. I want that to go over the tunnel. So first, let's remove some of the unnecessary things we have here, like the IP subnet 0, the IPsef. You'll see that the configuration examples, a lot of the times they'll just leave unrelated configs in, where this would be one of the first things that you would want to do when you're using their examples. Try to minimize it so that you have just the pieces of syntax that are really specific to that individual feature. So I don't need to know about their interfaces that they're using for the connections. I do need to know about the virtual template, though. And then I have an address pool. I don't need to worry about their routing. So this is going to be the most basic functionality. So now let's start with our phase 1 and work up from there. We have a phase 1 policy. It says we're using triple DES encryption, pre-shared authentication, group number 2, and then the hash most likely is going to be default to SHA in this iOS version. Now, once the user comes in and does the phase 1 authentication, we then need to check their group information. So this is where the crypto ISAKMP client configuration group is. This name here, this is what we would put into the VPN client. Whether this be the iOS router or whether this be the actual client like on Windows, this is what we're going to specify as the group username. Then we have the group key or the group password, the pre-shared key. So I know what the group name is, I know what the password is. Then I have a user that is going to be for the extended authentication. So for simplicity, I'll make these username and password Cisco. Password for group number 1 is also Cisco. Then I have my pool that is going to control what's the IP addresses that the users are assigned. So we have a pool allocated. It's called group 1 pool, where group 1 pool says we're using the range 192.168.1.1 to 192.168.1.4. So then obviously if we wanted more than 4 hosts to be able to use the tunnel simultaneously, we'd have to make the pool larger. So let's say up through 254. This is where I would also specify my access list. If I wanted to do split tunneling, which in this particular case I do, I want to protect traffic just that is going to that 172.16 network that's behind router 3. And again, remember that this access list is going to be from the perspective of the server. So on router 3, we'll say that the traffic is coming from the 172.16 network, but we don't necessarily know where it's going yet because we don't know who the initiator is of the tunnel. We'll say IP access list extended. We'll say this is the DVTI split ACL, which is I'm going to permit IP traffic that is coming from my local networks, which is 172.16, and I don't know where it's going, so it can go anywhere. Then this access list DVTI split ACL, this is going to be called from the client configuration group. Now, I don't technically need to do this. If I were to leave the access list off, it would mean from the test PC, it's going to send all traffic over the IPsec tunnel. It just depends if I want certain networks to be routed over the tunnel and then the default route to use their normal interface in the clear. So now we know the group username, we know the group password, we know the IP addresses the users are going to get, we know the access list that they're going to get. Next, we have the ISAKMP profile. This, again, is what is going to associate the user with the particular dynamic interface. So we have the group name, which is group number 1. They're saying that when this user comes in, we're going to authenticate them and authorize them with the local list. This is a AAA list that we're defining. It says check the local database. We could likewise send this to TACAX. We could send this to Radius. But the key is that this is now on a per group basis. Additionally, it says that the client is going to ask for an address. We're going to respond. We're going to then assign them to interface virtual template 1. Virtual template 1 is going to have an IPsec profile, which is the test-VTI1, which says that we're calling this particular transform set. This particular transform set says these are the phase 2 options. We're using triple DES and SHA, both with ESP. So otherwise, then, the only thing that we would need to change is possibly the address of the tunnel. Like, let's say we're going to unnumber this to the loopback address of router 3. It doesn't really matter what this address is as long as IP is enabled on the tunnel. Because just like any other interface on the router, we cannot route IP on it unless the IP protocol is actually enabled. Then the IP virtual reassembly, this is a fragmentation feature. We don't necessarily need to put that there. But in most real deployments, you would leave that on. Okay, so let's try this configuration out now. And additionally, notice that there's no crypto map. Previously, we had the crypto map applied on the incoming interface for the server, which is this one. But now, technically, router 3 could accept an easy VPN session on this interface, or this one, because the virtual tunnel is listening for all traffic that is locally destined to router 3. So now let's try this out. Let's go to router 3. Paste this config in. Looks like most of their example is good. Did generate one message here. It says a profile is deemed incomplete until it has a match identity statement, which was then the next thing that we did. So everything looks good here. Next, let's look at the debug crypto ISAKMP. And we'll now initiate the tunnel from the end host. So let's open the VPN client. We're going to start a new tunnel. This is going to go to router 3. And if we look at those settings again, the key point here is the group name and the group password. This group 1, this is what we need to define here as the group authentication name. Password is then going to be that key of Cisco. The host is going to be any address on router 3. I'll say it's the link between router 2 and router 3. We'll say this connection entry will say R3 group 1. Now, if we look at the debug on router 3, as we're connecting the tunnel, as soon as we hit the connect button, if I then see the username and password box appear, it means what is true about the tunnel? It means that the phase 1 negotiation was correct. Because remember that individual username and password box, that is for extended authentication. And extended authentication doesn't occur until phase 1.5, which means that your basic phase 1 has to work before you can get to 1.5. So if we now look at router 3, eventually what we should see is that they agreed on the ISAKMP policy, where they're going to use triple DES, SHA, group 2, and extended authentication with pre-shared authentication for the group. The attributes are acceptable. Now phase 1 is complete. We're now going to move on to the extended authentication. If we actually log in here, let's say username Cisco, password Cisco, we should now see the mode configuration attributes. It says we're assigning the address 192.168.1.1. Then we're sending them the access list dvti underscore split underscore ACL. Then once phase 1.5 is complete, we see they started negotiating the actual IPsec transform set. So now phase 1 is completely done. Eventually they agree that we're going to use ESP triple DES with HMAC SHA. We're running in tunnel mode. This is the particular Security Association lifetime. If we now look at the show crypto ISAKMP SA, we should see the phase 1 tunnel is complete. The state is QM idle or quick mode idle, which means that we're now moving on to phase 2. Now notice additionally here it says that this is for VPN 1-RA. And if we show run include VPN 1-RA, that is the name of the ISAKMP profile. So it means that this individual phase 1 tunnel landed on that particular profile. And that was based on the group address, or the group name, I should say. If we now look at the show crypto IPsec SA, it says the interface we're using is now virtual template 2, or virtual access 2, which is an instance of virtual template 2. The Security Association is going towards 192.168.118.100, specifically for this address. This is what we assigned to them. Now, right now, since we are not going through network address translation, we have not offered them NAT traversal or NAT transparency, which means that this is going to be natively encapsulated inside of ESP. Which again would then assume that from the test PC that we have proper ESP transport to the server and from the server back. In this particular case on the ASA, the way that I'm allowing this, if we look at the show run policy map, is by inspecting the ESP traffic as it's going through. Again, the other alternatives to this would be to manually allow the ESP in. I could configure a network address translation on the ASA, which is then going to force the iOS's VPN server to offer the client NAT transparency or NAT traversal, or I can configure it to tunnel it over TCP. So it really doesn't matter which option I use as long as I can get it functional. And if we now go back to the Windows machine, if we look at the routing table, we could say either route print from the command line, or we could go to the VPN client and look at the statistics. The route details, this is going to be that split tunneling access list. Under the tunnel details, it says that we have this particular crypto map, so it's triple DES, SHA. Transparent tunneling is off, or it's inactive, so we're running natively over ESP. So now let's actually send traffic out the tunnel and see if this encryption and decryption is going to increment. Let's ping 172.16.4.4. Says the traffic is getting encrypted. Traffic is getting encrypted, but there we go. Now it's coming back in. So this portion here, this was most likely just convergence of the tunnel on the server's end. If I were now to telnet to that address, let's telnet to router 4. If we log in, then look at the show users, we should see this coming from the host network address translation address. So this is the one that is assigned to the tunnel interface. And we can see this asterisk, this is our active session here, so ignore this one. Now if I were to telnet to someone that is outside of the tunnel, let's say I telnet to router 2, for example, and show users, the address now is my original address. It means that this traffic is now not being sent out the tunnel because the split tunneling ACL says that I would not use the tunnel to get to 200.0.0.2. I'm only using it to get to devices that are in that 172.16 network. So we can see here from the VPN client's perspective, there's no change. It doesn't know whether we're using the virtual tunnel interface on the head end or whether we are using the dynamic crypto maps. On router 3, if we look at the routing table, automatically when the client connects, there is going to be a static route for that particular host on that individual virtual access. Now, if we were to have an additional client, let's say we were to go to router 5, and we're going to configure router 5 with the software client, where this is our outside interface, this is the inside interface, and we want all traffic that's going this way to be translated to some address that router 3 is assigning. So same configuration logic as we did before. Again, the only thing that we need to do here is define the group username and password, define the peer address, and then apply the client to the interface. So we'll say crypto IPsec client. It's an EasyVPN client config. This name here, it could be whatever. We'll say EasyVPN client name. What is important is what is the group username. So the group that router 3 is listening for is group 1 with the key of Cisco. The peer's address is 200.0.23.3, and the mode that we're going to use is client. We could use network extension or we could use network plus, and result is going to be the same from the previous configuration examples we did. So now on the interfaces we have on Fast Ethernet 0/1, this is our outside. Fast Ethernet 0/0 is the inside. So we'll say crypto IPsec client, EasyVPN, and then the name of the config. So EasyVPN client name. This is the outside. Fast Ethernet 00 is the inside. Now, if the tunnel is working properly, we should get this log message that we need to do extended authentication. Username Cisco, password Cisco. We can see from router 3's debug of crypto ISAKMP, we're going through another phase 1 negotiation. We should see that there's a new address that is assigned to the tunnel. And on router 5, this is assigned to its loopback. So if we show IP interface brief, we can see as part of the VPN pool, I was assigned the 192.168.1.2 address. On router 3, if we look at the routing table, we should see two separate entries now, one that is for the Windows machine, the test PC, and then one that is for router 5. Now, the key point about this functional difference of using the dynamic virtual tunnel interfaces versus the crypto maps is that I can now easily classify traffic that is going to the Windows machine versus the traffic that's going to router 5. Because there are two separate interfaces essentially that we're using. One is for virtual access 1, one is for virtual access 3. Actually, virtual access 2 and virtual access 3. Now, I could even take this one step further and say that based on the group authentication, which again is going to be controlled by now the ISAKMP profile. If we show run section crypto, we could define a new ISAKMP profile that says we'll look for a different group address. Let's say that we're going to use group 2, where we'll take this previous configuration. It's going to be similar, but we're going to change it around a little bit so that there's a separate virtual tunnel interface. So we'll have a new configuration group. We'll say this is group 2. All of the other configuration is going to be the same there. But for profile VPN2 RA, we'll say as group number 2, we're going to assign them to interface virtual template 2. This would then mean we have a new interface. If we show run interface virtual template 1, means I have a new interface here. I could still use the same crypto profile if I didn't want to change the transform set. But now it's allowing me to categorize users that authenticate with group 2 separately than users that authenticate with group 1. So now let's say, for example, that if someone authenticates with group number 2, I want to put some restrictions on what type of traffic they can send into the network, where maybe I want to allow them to run everything except do ICMP pings, where we could say access list, IP access list extended. We'll say VPN to filter that says deny ICMP traffic but permit anything else. Now, for the application of this, since we have an interface that is associated with the tunnel, there's nothing else that's special other than saying IP access group VPN2-filter in, or access group VPN2-filter out. But now the functional difference of this is dependent on how the user authenticates. So depending on their group username and password, it's going to either assign them to interface virtual template 1 or virtual template 2. If we were to look at the other options of the crypto profile, let's say show run section crypto ISAKMP. We have two different profiles, one for group 2, one of them for group 1. Some of the other options we could change here would be the QoS identifier. So we can classify with an internal marking what's the difference between the group 1 users versus group 2. Then I could say maybe based on how someone else is authenticating, I'm going to give them a different bandwidth limitation, or I'm going to give them low latency for their voice over IP traffic. I could also say based on the group name, I'm going to use a different certificate authority. So I could say that maybe I have two different CA servers. If you authenticate with group number 1, then you're going to get CA server 1. But if you authenticate with group number 2, you're going to get a different one. So let's try this out now. If we were to go back to the Windows machine, and we can see right now if we're authenticated to group number 1, I should be able to ping router 4 no problem, because we're not filtering anything out. If I disconnect, we could see the traffic is still allowed. The difference now, if I were to go to router 4, and let's look at the debug IP ICMP, when the tunnel is not configured, or when the tunnel is not active, these pings are coming from the normal address of the test PC, the 192.168.118.100. Once the tunnel comes up, so let's reconnect the tunnel again. We should see the destination is going to change, so now it's the tunnel address. And if we were to authenticate again, but now we're going to do this to a different group. So let's disconnect this one. I'll make a copy of this. Let's duplicate the session. But we're going to modify it so it has a different group name. We'll say this is router 3 group 2. And we can see now the new filter is being applied. Where router 3 is dropping the packets, it's then responding back with an ISAKMP unreachable. It's then replying back with an ISAKMP unreachable, which is the administratively prohibited. If we were to now go to router 3 and look at the show crypto ISAKMP SA, we can see we have the phase 1 tunnel, which is fine. If we show the crypto IPsec SA, says that this host, which is, and let's actually see which one it is. If we go to the Windows machine, let's look at the IP config. This endpoint of the tunnel is 192.168.1.4. On router 3, if we look at the particular IPsec SA for that address, the 1.4, it says this is using interface virtual access 2. We see the particular transform set that's assigned, but I could technically do a different one if I wanted to, because I have different virtual templates, which means I have different crypto IPsec profiles. We show run interface virtual template 1 versus template 2. Again, the assignment between them is now based on the ISAKMP profile. Now, the other variation of this configuration would be on the IPsec client, which is router 5. We could change its EasyVPN client configuration so that it's also referencing a virtual template. This would then allow us to do different QoS parameters, different filtering parameters, based on the particular tunnel that they are assigned to. So again, the goal of using these dynamic virtual templates or virtual tunnel interfaces is that we have an interface associated with the IPsec tunnel without having to add the additional overhead of GRE or to run some more complicated design like DMVPN for multi-point GRE tunnels. So next, let's look at our current configuration on router 5. If we look at the show run section crypto, we have the IPsec client configuration where we're specifying the group name, we're specifying the group key, the peer, then we have the actual client applied on the interfaces where we have the Fast Ethernet 0/1 applied as the outside interface, and then Fast Ethernet 0/0, which is going to router 6, that is the inside interface. Now for the dynamic virtual tunnel interface variation of this, it's only a minor change from what we see as the current configuration, but we are going to specify what is the particular virtual template interface that we want for the client configuration. So before I make this change, first thing that I want to do is to remove the previous client configuration from the interface to make sure that we don't run into any type of order of operations problem. So on Fast Ethernet 00, we'll remove the inside interface. On Fast Ethernet 01, we'll remove the outside interface. If we now look at the show run section crypto, we have the client configuration, and actually it's still on the inside interface, so let's remove that. But notice the log message, it says that the loopback interface changed to down. This was because the tunnel was previously working. Then since we removed the configuration, it had to disconnect the IPsec SA. So our next step on router 5 is we're going to configure the new virtual template interface that we're going to use as the dynamic virtual tunnel interface, or the DVTI. We'll say that this is interface virtual template 1, give it any arbitrary number, but the key is that this is a special type that is for tunneling. Then, just like on the server, we need to make sure that we have an IP address. It doesn't necessarily matter what it is, as long as IP is enabled. So we could put a new primary address, we could put an unnumbered address, we'll say we're unnumbered to the loopback, as long as IP is running there. Then additionally, under the client configuration, here we're going to specify that this configuration is then tied to that virtual interface, or that is the virtual template number. Then we need to reapply this configuration on the physical interfaces. So on Fast Ethernet 0/0 and Fast Ethernet 0/1. So this is now again, the inside interface. FA01 is the outside interface. Next, let's look at the debug crypto IPsec client for EasyVPN, and we should be able to see router 5 attempting to connect the session. If we look at show crypto ISAKMP SA, we don't have any phase 1 negotiation. So now let's attempt to send traffic out the interfaces. From router 4, or router 6 I should say, let's send traffic to router 4 to 172.16.4.4. And ideally we should see the debug on router 5. Now, since I don't see the phase 1 tunnel trying to negotiate, most likely what this means is that either the interesting traffic is not triggering the tunnel, maybe I don't have the tunnel properly applied to the interfaces, or that router 3 is not actually listening for the connection. Now, we do already know that router 3 is listening for the connection, because both the Windows VPN client was working before, and router 5 when it was running the normal EasyVPN remote as the original software client. So now let's double check on router 5 that this is properly applied. Let's look at the show crypto IPsec client. EasyVPN, it says that the inside interface is Fast Ethernet 0/0. Outside interface is Fast Ethernet 0/1. The current EasyVPN peer is 200.023.3, which is what we want. If we look at the show IP interface brief, ideally what we should see is that there's going to be an IP address that is assigned to the virtual access. Now, you may find that this configuration is a little bit more sensitive to the order of operations than the previous one when we're not using the virtual tunnels. So let's look at this one more time. I may need to remove the configuration and then reapply it. But let's try to clear it. Let's say clear crypto IPsec client, EasyVPN. Then try to initiate traffic. Let's ping 172.16.4.4. Still no debug output. We could try to manually initiate the tunnel with the crypto IPsec client EasyVPN connect command. But it says the user connect request is ignored because the tunnel endpoint is not ready for a request. So let's see what else we could possibly be missing in the config. Let's say show run section crypto or interface. We have the group name, we have the group password. We're running in client mode. We have the peer address defined. We have the virtual interface defined. The virtual interface should be of type tunnel, which it is. Then we have the client configured on the outside interface and the inside interface. So it looks like the configuration should be solid. What I'm going to do now, just to make sure it's either a configuration problem or unrelated to configuration, is to save router 5's configuration and then reload. So now we can see router 5 has been reloaded. And notice one of the first log messages that comes up here, it says that there's now a pending extended authentication request, and we need to send our username and password. So the key point of this demo here is that you need to make sure that you do include reloading as part of your troubleshooting process. Especially when some of these configurations, you're making a lot of changes, adding new stuff, removing old stuff. Sometimes the IPsec process will get hung, where if removing the crypto map off the interface and reapplying it doesn't work, then as a last-ditch effort, you can reload, move on to something else, come back later and see if that has changed the problem at all. Now, what we should see as the final result of this, if we look at the show IP interface brief, that the address that is allocated from the VPN server should be assigned to a virtual access. And this is now the actual logical instance of the dynamic virtual tunnel interface. Also, if we look at the routing table, we should see the split tunnel ACL installed as a static route via the virtual interface. So now router 3, who is the server, is dynamically advertising 172.16.0.0/16 to us. And if we try to send traffic to any of these destinations, we can see it is working. If we were to telnet there, then look at the show users, router 4 is saying that 5's connection is coming from inside of the IPsec tunnel.